So I'm going to remind y'all about a few properties of exponents. So the first one is the product of powers property. This one states that we can multiply powers with the same base by adding the exponents. So an example of this would be x squared times x to the fourth equals x to the sixth. We got this by adding the 4 and adding the 2 because x is the same base, so all we had to do to multiply it was add the exponents, and we got x to the sixth. The second property is power of a power property. So this one states that to raise a power to a power, we multiply the exponents. So for example, if we have x to the fourth, and then we raise that to the second power, all we have to do to raise this power to this power is multiply them. So 4 times 2 is 8, so that equals x to the 8th power. The next power is power of a product property, and this says to raise a product to a power, we raise each factor to a power. So what that means is, let's say we have x times y, and x times y is a product, so say we're going to raise that to the fourth power. To raise x times y to the fourth power, that's the same thing as saying x to the fourth power, y to the fourth power. So to raise this whole product to a power, we're actually raising each factor to that power. The next one is the quotient of powers property. It says that we can divide powers with the same base by subtracting the exponents. So what this means is if we're doing x to the sixth divided by x squared, all we have to do is 6 minus 2. We're just subtracting this 6 minus that 2, and we're getting x to the fourth. So then the next property is power of a quotient property. It states that we can raise a quotient to a power by raising both the numerator and the denominator to that power. So what that means is if we have x divided by y, we have that quotient, and we're trying to raise it to a power. So say we're raising that to the power of 4. All we have to do is raise the numerator and the denominator by that power. So it's the same thing as saying x to the fourth divided by y to the fourth. Okay, another small reminder is that anything to the 0 power is 1. So 1 to the 0 power equals 1. 2 to the 0 power equals 1. 3 to the 0 power equals 1, and so on. Anything to the 0 power automatically equals 1. So now I'm going to show you the examples from the notes. So first of all, the first line, it says, for any non-zero rational number a, an integer m, a to the negative m power equals 1 over a to the m power. Okay, so basically what that's saying is if you raise something to a negative power, it's the same as putting 1 over it with it raised to the positive power. So like if you're raising 2 to the negative fourth power, that's the same as saying 1 over 2 to the positive fourth power. Okay? So we're going to look at A through F, but I'm going to write on this blank sheet of paper just so I have more room. So A says 3 to the negative 2 power. So we just read up there that if we're raising something to a negative power, we put 1 over it, and then in the denominator, it's that number to the positive power instead. So all we have to do to put this to the positive power is say 1 over 3 squared. So that changed it from a negative 2 to a positive 2 since it's in the denominator now. And then, of course, what is 3 squared? That's 3 times 3, which is 9. So the final answer is 1 over 9. And then, let's see. B is 2 to the negative 3 power. So we do the same thing here. We say 1 over 2 to the positive 3 power. And then that's 1 over, so that's 2 times 2 times 2, which is 8. So it's 1/8. Okay? And then on C, that one is 3 to the negative 2 power times 3 to the 5th power. So let's change these both into fractions so we can multiply them. So 3 to the negative 2 power is the same as saying 1 over 3 to the positive 2 power. And then we're going to multiply it. We're going to multiply it times 3 to the 5th power over 1. Because 3 to the 5th power is the same as 3 to the 5th power over 1. We just made it into a fraction so that these are both the same form. That way we can multiply them. So 1 times 3 to the 5th is 3 to the 5th. And then 3 squared times 1 is 3 squared. And then we can remember our property that says when we have the same bases, in order to divide, all we have to do is subtract. So we would do 5 minus 2. So that equals 3 cubed, which equals 3 times 3 is 9, 9 times 3 is 27. So that's our answer. So my camera stopped recording while I was doing example D. So I'm just going to show y'all what I did. I already have the steps written out, but I'm just going to talk you through it. So it's 16 squared times 8 to the negative 3 power. So I'm going to change those into fractions so I can multiply them. So I'm going to bring the 16 squared down and put it as 16 squared over 1. And then I'm going to bring down the times. Then I'm multiplying that times 1 over 8 to the positive third, since that's how we change it from a negative to a positive. And then I'm going to multiply these. So 16 squared times 1 is 16 squared. 1 times 8 cubed is 8 cubed. 16 squared is 256, and 8 cubed is 512, and that reduces to 1/2. Okay, so example E says x cubed y to the negative 2 power, and it has all of that to the negative 4th power. So there's a couple ways we can go about this. I'm going to show you all the way that I think is the easiest. So what we remember is back to our properties of exponents. We remember that when we're raising a power to a power, all we do is multiply those numbers. So this is the same as saying x to the third to the negative 4th. So 3 times negative 4 is negative 12. So that is x to the negative 12. Negative 2 times negative 4 is positive 8. So that's y to the positive 8th. And then we're going to look at it kind of the same way. Remember, there's an assumed times right there. So we're going to look at it just the same way we looked at example C and D. So we're going to make these into fractions. X to the negative 12th is the same as 1 over x to the positive 12 times y to the 8th is the same as y to the 8th over 1. So 1 times y to the 8th is y to the 8th, and x to the 12th over 1 is x to the 12th. Okay? The other way of doing it would entail putting the entire thing on the bottom and making this a positive 4, and then you would multiply it out and you would put the y on top because it would remain negative anyway. So you come out with the same answer, but this way is easier. Okay, now let's look at example F. It says true or false, a times b to the negative 1 equals a to the negative 1, b to the negative 1. So when I'm looking at our properties, that does look similar to the power of a product property, where when you raise this product to 1 power, you raise each one to the same power. However, these are in parentheses. When two things are in the parentheses, then the power applies to both of them. However, in this one, they're not in parentheses. This is just saying a times b to the negative 1. So the negative 1 does not apply to the a and to the b, because this is a to the 1 power. That's just a. So I would say false. Okay, and that's it.